Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling through the story of cosmic origins. From the soft hush before time existed, to the rise of stars, galaxies, planets, and life itself, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the ancient universe. We'll wander through the gentle unfolding of matter and light, the first galaxies swirling like brushstrokes, the birth of our sun and earth, and finally, the quiet, far future that waits in the dark. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, sink a little deeper into your pillow, and let's begin. Fact 1. The quiet before time. Long before anything existed, before light, before space, before the idea of before, the universe rested in a state we can barely imagine. It wasn't darkness, because darkness needs space to sit in. It wasn't silence, because silence needs time to pass. It was a kind of pure stillness, a cosmic pause with no edges at all. In this quiet, everything that would ever be, every star, every atom, every thought, was contained in an impossibly small, impossibly calm point. Nothing was moving. Nothing was becoming. It was a moment that held the potential for all stories. And from this peaceful stillness, the universe waited, gently, for its first breath. Beyond that stillness, a tremor of change was ready to whisper. Fact 2. The first hint of a beginning. When the universe finally stirred, it didn't erupt like an explosion. Instead, it expanded, softly at first, then faster, stretching the fabric of reality in every direction. In a fraction of a moment, space itself began to unfurl, smooth and warm with newborn energy. This expansion wasn't violent. It was more like a quiet blooming, a flower opening in a single heartbeat. The tiniest quantum ripples, little fluctuations too small for any eye to see, became the seeds that would one day grow into galaxies, stars, and planets. As the universe swelled outward, the early energy glowed like a warm fog, gentle and diffuse. Everything was light, spreading thin across a still growing sky. And within that brightness, the first patterns of creation began to form, patient and unhurried. Beyond this glow, the universe continued to open like a morning horizon. Fact 3. A seed, smaller than a whisper. Scientists sometimes describe the early universe as beginning from a region smaller than a single grain of dust. Yet inside this tiny, trembling seed lay enough energy to sculpt every world we will ever know. In that compressed beginning, the laws of physics settled into place. Gravity, light, time, and the gentle balance that makes everything work. Imagine holding all the stars of the sky in the palm of your hand, tucked into something no bigger than a speck. It's a humbling picture, one that reminds us how delicate beginnings can be. As space continued to stretch, this seed relaxed, cooling slightly, letting matter take its first quiet shape. Particles whispered into being, drifting into the earliest arrangements. And just beyond those first particles, the universe waited to grow even more. Fact 4. The moment everything expanded. As the universe continued its first great breath, its expansion grew swift and sweeping, like a quiet tide rising through a boundless shore. Space stretched faster than light itself could travel, not breaking any rules, but carrying everything with it. A gentle swelling of reality. Temperature soared in this early moment, yet the warmth wasn't harsh. It was uniform, smooth, a serene glow filling every direction at once. In this vast, soft brightening, matter and energy danced in a delicate equilibrium. They were too tightly woven to become anything solid yet, drifting in a haze of motion and possibility. The universe was young, but it was already full of promise. And as it expanded, it cleared room for the first structures to someday take shape. Beyond that widening canvas, new complexity waited in the wings. Fact 5. Light's earliest footprints. In the first few minutes after the beginning, the universe cooled just enough for its energy to begin settling into the earliest ingredients of matter. Photons, tiny packets of light, zipped through the dense cosmic fog, but they didn't travel freely. Every time they moved, they bumped into charged particles, scattering like tiny fireflies trapped in a mist. These interactions left a soft imprint on everything around them, a warm afterglow that clung to the fabric of space. We can still see this ancient light today, stretched into a faint microwave hum that fills the entire sky. It's one of the universe's oldest memories, the first gentle footprints left by traveling light. In that glow, the story of early space is written in delicate patterns, and beyond it, atoms would soon begin to assemble. Fact 6. The birth of the first particles. As the universe continued to expand and cool, individual particles formed quietly, like tiny sparks condensing from a fading fire. Protons and neutrons came together first, strong and steady, held close by the forces that emerged in those early instants. Electrons drifted nearby, light and quick, waiting for the universe to calm enough for them to settle into place. In this era, matter existed as a warm ocean of free-floating pieces, not yet atoms, but the ingredients of everything to come. These particles moved through space in smooth, swirling currents, guided by temperature and time. They were the simplest forms the cosmos could create, but they carried the blueprint for stars, planets, and life. And beyond this drifting sea of particles, the next step waited. The first atoms would soon be born. Fact 7. A universe of cooling glow. As the minutes turned into hours in that young cosmos, the once searing heat began to ease. The universe stretched wider, and with that stretching came a calm, steady cooling. Like a warm breath drifting outward into a larger room. Matter moved more slowly now, no longer pushed into frantic motion by the intense newborn heat. The cosmic glow softened, becoming a comforting radiance that filled every corner of expanding space. This cooling didn't happen in a rush. It was patient, gentle, the kind of change that takes its time. In this peaceful dimming, the universe came closer to a state where structure could emerge. The frantic early brightness faded into a mellow warmth. And beyond that glow, the conditions for the first true atoms were quietly falling into place. Fact 8. The first atoms drift free. After about 380,000 years, a blink on cosmic scales, yet an eternity for a newborn universe, space had cooled enough for electrons to finally settle down. Instead of darting wildly through a bright fog of particles, they nestled close to protons, forming the very first hydrogen and helium atoms. It was a moment of quiet stabilization, like tiny families of matter finally finding each other. When atoms formed, light was suddenly free to travel through the universe without getting trapped. The fog lifted. space became transparent for the first time, revealing a vast openness stretching in every direction. The soft radiation from that moment still glows around us, a faint amber memory called the cosmic microwave background. With atoms drifting peacefully, the universe entered a gentler era. And beyond this clarity, gravity would begin its patient work. Fact 9. Dark matter's gentle scaffold. Not all matter in the universe behaved like the atoms we know. Invisible and silent, dark matter moved through the early cosmos without shining or colliding, guided only by gravity. Though unseen, it gathered into great, ghostly clumps, quiet structures that would become the hidden framework for galaxies. Imagine delicate nets spreading through the darkness, shaping pathways for ordinary matter to follow. Gas and dust, light and atoms, all slowly settled into these unseen hollows, like soft snow collecting in the curves of a quiet valley. Dark matter didn't glow or speak, but it created the stage on which everything luminous would form. Its presence shaped the universe more deeply than any star ever could, and beyond those invisible foundations, the first cosmic structures began to stir. Fact 10. The universe learns to slow. In its earliest moments, the universe expanded with breathtaking speed, but over time, that rush began to ease. As matter gathered and gravity grew stronger, the stretching of space no longer raced ahead quite as quickly as before. It was as though the cosmos took a long, steady breath and then slowly exhaled, settling into a calmer rhythm. This gentle slowing allowed tiny differences in density, slight ripples in the early fog, to become more pronounced. Some regions grew a little heavier, others a little emptier, creating the first hints of structure. The universe was no longer a perfectly smooth glow. It had texture now, the soft grain of a story beginning to take shape. And beyond that slow shift, the great cosmic web was ready to awaken. Fact 11. The great cosmic web awakens. As hundreds of millions of years passed, gravity began weaving matter together on enormous scales. Atoms drifted toward regions rich in dark matter, collecting in threads that stretched like glowing filaments across the vastness. These strands formed the earliest outlines of what we now call the cosmic web, a sprawling, interconnected structure so large it defies imagination. Picture a delicate lacework draped across the universe, each thread a pathway of matter gently flowing toward the knots where galaxies would someday bloom. The spaces between these filaments grew emptier, while the filaments themselves thickened with time. Though invisible to any human eye, the cosmic web is the quiet architecture of everything. And within those threads, the first gathering clouds began to deepen. Fact 12. Filaments stretch across silence. As the cosmic web grew more pronounced, its filaments extended across unimaginable distances, millions of light years long, yet incredibly thin compared to the strength they carried. These strands were rivers of matter, slowly feeding the growth of the earliest structures. Hydrogen gas drifted along them like gentle currents in a still ocean, guided always by gravity's patient pull. Where filaments intersected, matter pooled more densely, forming soft, luminous knots. These knots were the seeds of future galaxies, clusters, and entire families of stars. The universe, once a simple glow, now resembled a quiet, interconnected tapestry. Everything we know, every world and every star, can trace its lineage back to these ancient threads. And from one of these tender crossings, the first shadows of galaxies began to form. Fact 13. The first shadows of galaxies. In the quiet intersections of the cosmic web, small clouds of hydrogen and helium gathered more densely than their surroundings. These clouds were faint, almost imperceptible, like soft shadows drifting against an endless backdrop. Yet within them rested the earliest hints of future galaxies. Gravity tugged at the gas, encouraging it to swirl and thicken over millions of years. Nothing yet shone inside these dim cocoons. They were dark, waiting patiently for the first sparks of starlight. But their shapes began to settle, forming loose, irregular clumps that would one day grow into majestic spirals and luminous clusters. These first shadows were the universe's earliest promise of structure, and as they deepened, gravity continued its gentle gathering. Fact 14. Gravity's soft gathering. As each protogalactic cloud grew denser, gravity became the quiet sculptor behind every new form. The gas within these clouds didn't collapse suddenly. Instead, it drifted inward with slow deliberation, like a mist settling over a valley. The motions were gentle at first, slight currents and eddies forming within the haze. Over long ages, the centers of these clouds grew warmer as particles brushed past one another, gradually collecting in the middle. The surrounding regions formed faint halos, wrapping each proto-galaxy in a cushion of material. Gravity asked for no haste. It worked with infinite patience, shaping the raw material of the cosmos grain by grain. And deep within these clouds, conditions ripened for a transformation that would illuminate the darkness. Fact 15. Tiny clouds become titans. From these modest beginnings, the first galaxies slowly emerged. What began as small, quiet clouds grew by merging with neighboring clouds, drawn together by the same gravitational threads that stitched the cosmic web. Each merging event was like a slow, celestial embrace. No sudden collisions, just gradual blending over millions of years. As more gas flowed inward, the growing structures swelled into titanic formations, spanning hundreds of thousands of light years. Though still dim and chaotic, they were becoming the ancestors of the grand spirals, ellipticals, and clusters that fill our night sky today. These early galaxies were unruly, full of swirling turbulence and raw energy, but they were alive with potential. And from within their thickening hearts, the first stars were ready to awaken. Fact 16. The first stars sparkle into being. Inside those young, uneven galaxies, pockets of gas continued to gather, growing denser and warmer with each slow drift inward. Eventually, in the calm heart of one such cloud, temperatures rose high enough for hydrogen atoms to fuse together. That gentle fusion released light, the first true starlight the universe had ever seen. These earliest stars were unlike the ones we know today. They were enormous, hundreds of times more massive than our sun, burning bright and intensely hot. Yet even in their brilliance, their glow felt like a promise, a soft lantern illuminating the vast cosmic night for the first time. With these stars, the universe finally learned to shine, and from their fierce warmth, the next steps of creation quietly unfolded. Fact 17. The brief lives of cosmic giants. The first stars lived fast lives, blazing through their fuel with incredible speed. Their immense mass made them luminous, but short-lived, like candles burning with flames too large for their wicks. In just a few million years, the blink of an eye on cosmic timescales, they reached the end of their radiant journey. Yet during their blazing lives, they performed an essential task. They forged heavier elements in their cores: carbon, oxygen, nitrogen, the building blocks of future worlds and future life. All took shape inside these giant celestial furnaces. Their brilliance was fleeting, but their legacy was eternal, woven into the chemistry of everything that would follow. And when their time ended, the universe prepared for its first great fireworks. Fact 18. The universe's first supernovae. When those colossal first stars exhausted their fuel, their cores collapsed swiftly and dramatically, triggering explosions of unimaginable beauty. These supernovae were the earliest of their kind, titanic bursts that sent ripples of light and matter sweeping across the young galaxies. But their role wasn't destructive, it was generative. In each burst, the elements forged inside the stars were swept outward into space, scattered like shimmering seeds across interstellar fields. These enriched materials mingled with surrounding gas, creating clouds with the ingredients needed to form new, more complex stars and planets. A supernova is both an ending and a beginning, a quiet reminder that creation often grows from release. And beyond these brilliant outbursts, the universe began filling with stardust. Fact 19. Stardust fills the dark. With each supernova, the universe grew richer. The heavy elements created inside the earliest giants drifted outward, carried on waves of expanding shock. These particles traveled through young galaxies like tiny, glowing embers, slowly cooling as they wandered. Some mixed into vast clouds of gas, while others floated freely through the quiet reaches of interstellar space. This stardust was delicate, each grain no larger than a speck, yet it carried the memory of a star's entire life. Within its structure lay the seeds of worlds, oceans, minerals, and life yet to come. It was the universe's way of saving its stories, scattering them gently, piece by piece, into the darkness. And as stardust gathered, new clouds prepared to awaken under gravity's soft hand. Fact 20. The era of Ryanization begins. As more stars formed across the growing cosmos, their light began to change the nature of space itself. Ultraviolet radiation streamed outward from these early suns, gradually breaking apart the once neutral hydrogen atoms that filled the universe. This process, called reionization, wasn't sudden or violent. It was a gradual brightening, like dawn spreading through a fog. Little by little, the soft haze that once made the universe opaque gave way to clearer, more transparent space. Light could travel farther, structures could be seen more easily. The cosmos was beginning to look more like the universe we recognize today. Open, expansive, and full of star-lit potential. The early darkness slowly lifted, revealing a sky ready for galaxies to take shape. And into this clearing, spiraling cities of stars quietly emerged. Fact 21. Spirals learning to swirl. In the billions of years that followed, many galaxies began to settle into graceful, swirling forms. Clouds of gas rotated around their centers, gradually flattening into wide, spinning disks. From these disks, spiral patterns slowly unfolded, not in sudden shifts, but through steady, elegant rotation. Each arm was a river of stars, dust, and glowing nebulae, all moving in long, quiet loops around a central mass. The spirals weren't perfectly smooth. They rippled with clusters and knots of star-forming regions, each one a small cradle of light. Yet from afar, they appeared serene, like cosmic pinwheels turning in frozen silence. These galaxies became some of the universe's most beautiful structures, and within their rotating arms, countless new stars were waiting to be born. Fact 22. Ellipticals in gentle crowds. Not all galaxies chose the elegant sweep of spiral arms. Some, born in crowded regions where galaxies gathered close together, grew into soft, rounded shapes called ellipticals. These galaxies resembled hazy, glowing spheres, vast congregations of stars that drifted together in a smooth, blended glow. Their stars were often older, quieter, and less active than those in spirals, giving ellipticals a calm, settled presence. They held little gas or dust, their materials long used up in early bursts of star formation. What remained was a gentle hum of ancient light, like a lantern glowing behind frosted glass. These galaxies were peaceful beacons in dense cosmic neighborhoods, and around them, interactions with neighboring worlds shaped the galaxy's destinies. Fact 23. Galactic collisions like slow dances. When galaxies wandered close to one another, gravity linked them in long, slow interactions that could last hundreds of millions of years. These encounters weren't violent crashes, but graceful dances. Two immense star systems circling, stretching, and blending. Stars rarely collided directly. Instead, their collective gravity pulled at each other's shapes, drawing out long tidal tails of stars and gas. Over time, these dances could reshape galaxies entirely, merging two into one. Spirals might become ellipticals, or irregular forms might settle into new balance. Each collision told a story of patience, of cosmic choreography playing out across unimaginably long stretches of time. Such meetings helped sculpt the universe's grand architecture, and through these dances, some galaxies grew hearts unlike any others. Fact 24. The calm of cosmic neighborhoods. Though the universe is vast, galaxies tend not to drift alone. They gather in gentle families called groups and clusters, held together by shared gravitational pull. In these neighborhoods, galaxies move quietly around one another, often separated by millions of light years, close on cosmic scales, yet far enough to maintain a peaceful distance. Our own Milky Way belongs to a small, tranquil gathering known as the local group, where galaxies float in patient orbits through a shared sea of dark matter. These communities create an environment of slow interactions and mutual influence, helping each galaxy grow and evolve over time. Cosmic neighborhoods are places of quiet companionship in the vast dark. And deep within many galaxies, another presence quietly shapes their paths. Fact 25. The growth of galactic hearts. At the center of most galaxies lies a region of remarkable stillness and strength. A dense, luminous heart where stars cluster by the millions. Over time, these central regions grew heavier as gas and dust drifted inward, drawn by gravity's steady pull. The motion wasn't rushed. It was a slow inward drift, like leaves spiraling toward the center of a quiet eddy. These galactic hearts became bustling hubs of starlight, where new suns ignited close together and older ones circled in tight, gentle orbits. Though busy on a cosmic scale, they gave off a warm, continuous glow, shining like lanterns guiding the rest of the galaxy's structure. Within these central gatherings, something even more mysterious was forming, and soon, a hidden presence would influence the motions of everything around it. Fact 26. Black holes. Quietly shaped worlds. Deep in the cores of many galaxies, including our own, supermassive black holes slowly grew. They did not roar or tear wildly through space. They simply rested, dense and silent, their gravity guiding the stars that circled close to them. These behemoths could be millions or even billions of times more massive than our sun, yet they occupied a region small enough to astonish the imagination. When gas drifted near them, it warmed and glowed, creating gentle halos of light that revealed the black hole's presence. But most of the time, These giants slept quietly, influencing their surroundings through subtle gravitational pulls rather than violent outbursts. They were like steady anchors in a swirling sea of stars. And around these anchors, the galaxies themselves began to take elegant shape. Fact 27. Clusters, wrapped in invisible halos. Not only galaxies, but entire clusters of galaxies found themselves wrapped in vast halos of dark matter. This invisible structure extended far beyond the visible stars, forming an unseen cocoon that held hundreds or even thousands of galaxies gently together. Though we cannot see the halos directly, their gravitational influence traces smooth contours through space, shaping the way galaxies move within their clusters. Within these expansive halos, galaxies drifted like glowing islands in a calm ocean, following paths set by masses they could not perceive. The dark matter around them acted as both container and guide, stabilizing these enormous communities of light. These halos offered a quiet framework for cosmic evolution. And within the safety of these spaces, stars continued to gather in brilliant constellations of light. Fact 28. Stars gather in bright cities. As galaxies matured, stars within them began arranging themselves into quiet communities, clusters, associations, and wide neighborhoods of light. Some clusters were tight and ancient, like globes of golden embers packed closely together. Others were young and loose, filled with newborn stars, still wrapped in traces of their natal clouds. These stellar gatherings often moved through their galaxies as cohesive units, drifting along graceful orbits shaped by gravity's patient guidance. From afar, they looked like glimmering cities in the night, each one buzzing gently with its own history and character. Within them, stars shared similar ages, compositions, and stories, small families in the vastness. These clusters became the building blocks of galactic beauty, and woven among them, threads of dust shaped the next wonders to come. Fact 29. Dust lanes, like soft brushstrokes. Throughout many galaxies, particularly spirals, long dark lanes of cosmic dust stretched across their glowing disks. These weren't empty shadows, but delicate clouds of tiny particles, the remnants of ancient stars mixed with gas drifting between stellar homes. From a distance, these dust lanes looked like soft brushstrokes, painted across spiraling arms, adding texture and depth to each galaxy's luminous form. Inside the dust, light from background stars was gently dimmed, creating subtle patterns of contrast and shadow. Yet within these subdued regions, the ingredients for future stars quietly collected. Dust grains stuck together, forming small clumps that could someday grow into dense clouds, the cradles of new suns. These dark strokes were not obstacles to starlight, but invitations for new creation. And in time, entire galaxies blossomed across the expanding universe. Fact 30. Galaxies bloom across time. In the billions of years since the universe's earliest days, galaxies have blossomed into an astonishing variety of shapes, sizes, and colors. Some whirl with elegant arms, others glow as smooth, rounded spheres, and still others appear chaotic, shaped by interactions or youthful turbulence. Each galaxy is a slow-growing bloom, unfolding across cosmic ages. As the universe expanded, galaxies formed, merged, and evolved, spreading like a field of celestial flowers across space. Their collective light filled the darkness with gentle radiance, turning the once empty cosmos into a tapestry rich with worlds, stars, and uncountable mysteries. Every galaxy carries the fingerprint of its past, a quiet story written in starlight and motion. And within these galaxies, the universe prepared to ignite countless new suns. Fact 31. Clouds of hydrogen. Exhale. Before a star is born, it begins as a vast, quiet cloud of hydrogen, so large that entire solar systems could drift inside it unnoticed. These clouds float through galaxies like soft, pale veils, lit faintly by the starlight passing through them. Within their cool depths, the atoms hardly interact, moving slowly, as though the cloud itself is breathing in long, measured cycles. Yet even in their calm, these clouds are full of quiet potential. Slight ripples of density, stirred by passing waves of energy, create small pockets heavier than their surroundings. These pockets begin to drift inward, losing heat and gathering mass. The cloud seems unchanged from afar, but inside, the first hints of collapse have begun. And within that inward pull, new suns wait patiently to awaken. Fact 32. Gravity's long, gentle squeeze. As these dense pockets contract, gravity becomes the guiding force behind every motion. It doesn't push or jerk. It simply invites matter to drift inward, softly but steadily. Over thousands of years, the pocket becomes a concentrated knot of gas, growing warmer as atoms nudge closer and closer together. This stage is peaceful and slow, the kind of transformation that unfolds in complete silence. Dust grains spiral inward with the gas, creating gentle swirls that shape the forming core. The region glows faintly in infrared light, heat slowly rising from deep inside. Eventually, the center becomes dense enough to form what astronomers call a protostar, a young star still wrapped in its cocoon of cloud and dust. And beneath that warm cocoon, a deeper change prepares to ignite. Fact 33. The spark of fusion. When the core of a protostar grows hot enough, something extraordinary happens. Hydrogen atoms begin merging, releasing tiny bursts of energy with each union. This is nuclear fusion, the quiet miracle that lets stars shine. It begins subtly, just a faint whisper of heat, then grows stronger as the core becomes stable and balanced. The moment fusion starts, the star takes its first true breath. Light streams outward from its center, pushing gently against the surrounding dust. Over time, the young star clears away its cocoon, revealing a newborn sun glowing softly in the dark of space. This light is pure, steady, and patient, the heartbeat of a star newly awakened. And with each newborn sun, a galaxy becomes just a little brighter. Fact 34. Starlight spreads through darkness. Once a young star begins to shine, its light drifts outward in every direction, filling the surrounding space with a warm, gentle glow. Even from great distances, this light softens the darkness, illuminating nearby clouds and dust in faint hues. Over time, the expanding light carves out a small, peaceful bubble around the star, a region where shadows retreat and new possibilities unfold. The starlight doesn't rush. It moves at its own steady pace, crossing light years in silent, unbroken waves. Along the way, it warms drifting particles, reflects off ice grains, and paints subtle colors into nebulae. In a universe once ruled by darkness, each star becomes a quiet lighthouse. And from these lighthouses, the cosmos slowly learns to shine as one. Fact 35. The colors of cosmic fire. Not all stars glow with the same kind of light. Some burn with cool, steady red hues. Others shine bright and blue, their surfaces many times hotter than our sun. These colors are more than beauty. They're gentle clues about a star's age, size, and temperature. Imagine walking through a meadow at dusk, each flower glowing with a different shade. The galaxy is much the same, a field of cosmic blossoms, each star revealing something about its story through its color. Red stars tend to be smaller and long-lived, while blue giants burn hot and fast, soon to change into something new. Together, these colors weave a soft rainbow through the night sky, and as stars age, their hues shift, whispering of changes deep within. Fact 36. The quiet, patient lives of suns. Most stars spend the majority of their existence in a peaceful middle age, steadily converting hydrogen into helium at their cores. This balanced process allows them to glow calmly for billions of years, neither too hot nor too unstable. Our sun is in this stage now, shining with dependable warmth and gentle golden light. During this long phase, a star's life is remarkably serene. It radiates energy outward, maintaining harmony between gravity pulling in and fusion pushing out. This equilibrium is like a slow, rhythmic inhale and exhale, a cosmic breath held for eons. Across the galaxy, countless suns exist in this tranquil state, lighting the darkness with steady, unwavering grace. And eventually, each one will drift toward the next chapter of its luminous journey. Fact 37. The breath of red giants. As a sun-like star reaches the later chapters of its life, its core begins to change. The supply of hydrogen slowly diminishes, and the delicate balance between inward gravity and outward fusion starts to shift. In response, the star expands, gently at first, then with increasing grandeur, becoming what we call a red giant. Its outer layers drift outward like a slow exhale, growing cooler and dimmer, even as the star itself becomes enormous. A red giant can swell to many times its original size, its surface glowing with a soft, warm hue reminiscent of embers at the end of a fire. Though vast, these giants radiate a sense of calm, as if settling into a comfortable old age. And within their glowing hearts, new elements quietly form. Fact 38. The white dwarfs that cool like embers. When a red giant finally sheds its outer layers, its core remains behind, a small, dense sphere called a white dwarf. This remnant no longer burns with fusion. Instead, it shines with leftover heat, glowing in steady silence. About the size of Earth, but with the mass of a star, a white dwarf is one of the most serene objects in the universe. Its light fades slowly over billions of years, cooling like an ember left to rest in the ashes of a long extinguished fire. It doesn't flare or erupt, but simply radiates its remaining warmth into space, growing dimmer with time. These quiet remnants are the final footprints of many stars like our sun, and far beyond them, stranger remnants await, born from far more powerful stars. Fact 39. The titans called neutron stars. For stars far larger than our sun, the end of life brings a more dramatic transformation. After a supernova explosion, the leftover core collapses into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Though intensely compact, neutron stars can spin rapidly, sweeping beams of radiation across space like cosmic lighthouses. Yet despite their astonishing properties, neutron stars often appear unassuming from afar, small and dim against the velvet dark. Their surfaces are incredibly smooth, their gravity immense, their structure almost entirely made of neutrons pressed tightly together. They are among the universe's strangest survivors, born from both destruction and renewal. And for the largest stars of all, an even deeper darkness awaits. Fact 40. Black holes, born from collapsed suns. When the most massive stars reach the end of their lives, their cores collapse so completely that not even light can escape their pull. What's left behind is a black hole, an object of profound stillness and unimaginable density. Despite their reputation, black holes are not cosmic monsters. They do not chase or consume. They simply rest where they are, quietly curving space around themselves. Most of the time, a black hole is perfectly calm, influencing its surroundings only through gravity. Stars and gas orbit safely at a distance, circling like dancers who understand the boundaries of the floor. Unless something drifts too close, the black hole remains peaceful, its presence known only through its gentle gravitational touch. These remnants mark some of the universe's most powerful endings, and yet, from their influence, new structures can quietly emerge. Fact 41. Elements forged in stellar hearts. Long before planets formed or oceans shimmered, the ingredients for everything familiar were being crafted deep within stars. Through the process of fusion, stars gently pressed atoms together, forming heavier and more complex elements over millions of years. Carbon, oxygen, silicon, iron, all were born in these hot, bright interiors. Each element told a story of time, pressure, and patient transformation. When stars died, they released these materials into space, where they cooled and drifted through galaxies. These wandering elements mixed like pigments on a cosmic palette, ready to become new worlds, new atmospheres, new beginnings. Every breath we take, every stone we touch, every drop of water we drink is made from ancient stellar work. And soon, these ingredients would gather into cradles of creation. Fact 42. Supernovae scatter the seeds. When a massive star ends its life in a supernova, its explosion sends newly formed elements hurtling outward at tremendous speeds. Yet even this dramatic event unfolds gracefully across great distances, its shock waves spreading like ripples across a vast cosmic lake. In these expanding shells of gas and dust lie the seeds of future solar systems, scattered, cooled, and carried gently into the wider galaxy. As the supernova's glow fades, the enriched material drifts into interstellar space, mingling with quiet clouds of hydrogen. Over time, these clouds absorb the heavy elements, becoming richer and more complex. The enrichment is subtle, slow, and beautiful, setting the stage for worlds that can support oceans, minerals, and eventually life. Each supernova is a gift to the galaxies around it. And from these gifts, new nebulae begin to bloom. Fact 43. Nebulae, like soft cradles. From the ashes of old stars, enormous clouds of gas and dust began to gather, drifting, glowing structures we call nebulae. These clouds were vast, stretching across light years, yet within their misty folds lay some of the most delicate processes in the cosmos. Illuminated gently by nearby starlight, nebulae shimmered in soft hues of pink, blue, and gold, like watercolor brushstrokes across the night. Inside their cool depths, gravity worked patiently, coaxing tiny clumps of matter to drift inward. These clumps would one day become stars, but for now, they rested in a state of tranquil suspense. Nebulae were nurseries, quiet sanctuaries where the next generation of suns found their beginnings. They were the universe's cradles of light, and within them, young stars soon gathered material into swirling disks. Fact 44. Disks that circle. Young suns around newborn stars, gravity pulled leftover gas and dust into wide, graceful disks. These protoplanetary disks spun gently, warmed by the soft light of the young sun at their center. From above, they resembled vast cosmic rings, thin at the edges, dense near the middle. and full of tiny particles drifting in slow orbits. Within the disk, collisions happened as whispers, not crashes. Dust grains brushed together, sticking lightly thanks to electric charges, forming clumps no bigger than sand. Over thousands of years, these clumps grew into pebbles, then boulders, and eventually larger bodies, with enough gravity to attract more material. This quiet gathering was the first step toward building worlds, and as these bodies grew, they began sculpting the disk into lanes and gaps. Fact 45. From dust to pebbles to planets. In the protoplanetary disk, tiny particles continued to join together, forming larger and larger structures. What began as drifting dust soon became solid clusters, each one tumbling gently through the circling cloud. With every encounter, these clusters grew stronger, forging the building blocks of future planets. As they gained mass, these early planetesimals influenced their surroundings. They carved paths through the disk, attracting smaller pieces into their gravitational embrace. Some merged peacefully, while others passed by in quiet spirals, shaping the architecture of the young system. Over millions of years, these growing bodies became full-fledged worlds. Rocky planets, gas giants, icy spheres, each one born from the quiet cooperation of dust and gravity. And from here, the universe began crafting the variety of planetary forms we see today. Fact 46. The sculpting hand of gravity. As young planets and planetesimals orbited their newborn star, gravity began shaping their paths with patient precision. Larger bodies tugged gently on smaller ones, creating subtle shifts in their orbits. Over time, these gravitational interactions carved elegant patterns into the protoplanetary disk, forming rings, gaps, and spiral waves of drifting dust. Though invisible to the eye, these gravitational ripples guided the assembly of entire worlds. A tiny change in one object's motion could influence countless others, like a soft ripple spreading across a quiet pond. The disk gradually organized itself into a harmonious system, each planet finding its place in a slow cosmic dance. These graceful motions built the architecture of planetary families, and in the far reaches of the disk, colder wonders were quietly forming. Fact 47. The frosty edges of early systems. Far from the warmth of a central star, temperatures fell until gases could freeze into solid ice. In these distant, dim regions, tiny icy grains drifted like frozen dust, shimmering faintly in reflected starlight. These particles clumped together, just as their rocky cousins did closer in, forming cold, gentle bodies, the precursors to comets and distant worlds. Here, water, methane, and ammonia froze into crystalline forms, creating a realm of quiet beauty and breathtaking stillness. Planet formation was slower in these icy outskirts, but just as important. The frozen materials preserved the earliest chemistry of the system, acting as time capsules for ages to come. These outer regions were peaceful sanctuaries of ancient ice, and from them, comets would someday journey inward, carrying memories of creation. Fact 48. The warmth of newborn stars. While the outer disk remained cold, the regions closer to the young star glowed with gentle warmth. Heat from the star illuminated the swirling material, causing gas to shimmer and dust to radiate softly. These inner zones were alive with motion, particles orbiting swiftly, colliding, merging, and growing under the star's watchful glow. This warmth created a boundary called the frost line, separating where ice could exist from where it would melt away. Inside this line, rocky planets formed. Outside it, icy worlds took shape. The star's gentle heat quietly sculpted the types of planets that would eventually emerge. The interplay between warmth and cold created a rich tapestry of worlds, and drifting through that tapestry, ancient travelers held stories older than any planet. Fact 49. Comets carry ancient memories. Comets are among the oldest travelers in any planetary system. Formed in the cold, shadowed outskirts, they hold materials unchanged since the earliest days of creation. Their icy bodies preserve the chemistry of the newborn universe. Water, carbon compounds, and delicate dust grains older than planets themselves. When a comet drifts inward, warmed by its star, its frozen surface begins to release vapor and dust, forming the glowing tails we see from afar. These shimmering trails are like the comet's breath, a soft exhale of ancient material returning briefly to the light. Comets remind us that even small, quiet objects can carry profound history. And while they roam the outer edges, rocky worlds closer in begin to take clearer shape. Fact 50. Asteroids as cosmic time capsules. In the calmer, warmer regions between planets, countless rocky fragments settled into their own orbits. These asteroids, remnants from the early construction of worlds, never grew large enough to become planets themselves. Instead, they remained as they were, solid pieces of ancient stone, unchanged across billions of years. Each one is a time capsule, preserving clues about the early solar system. Their surfaces hold the marks of collisions long past, and their minerals reflect the environment in which they formed. Some are metal-rich, others dusty and porous, each telling a slightly different story of how planets began. Though small, asteroids are invaluable records of primordial time. And beyond these scattered stones, entire worlds were quietly coming into being. Fact 51. Rocky worlds in the inner glow. Closer to the newborn star, where heat kept ice from surviving, solid rock accumulated into young terrestrial planets. These worlds began as molten spheres, their surfaces glowing faintly as they cooled from the heat of countless collisions. Over millions of years, they hardened into crusts of stone, slowly forming mountains, valleys, and basins. The inner worlds were compact, dense, and full of dynamic energy. Their proximity to the star meant shorter orbits, quicker days, and strong sunlight shaping their early atmospheres. Though each planet evolved differently, all shared the same simple origin: dust, heat, and time working together in quiet harmony. These rocky worlds would become the foundations for everything from oceans to life. And farther out, another family of planets grew beneath gentler, cooler skies. Fact 52. Gas giants in the outer calm. Farther from the warmth of the star, beyond the frost line where ice could survive, the protoplanetary disk offered different ingredients for planet making. Here, vast cores of rock and ice grew large enough to pull in tremendous envelopes of hydrogen and helium. Over time, these cores swelled into gas giants, enormous planets with thick, swirling atmospheres and deep, mysterious interiors. These worlds formed slowly, gathering material from the disk with quiet persistence. Their outer layers remained cool, tinted in soft blues, creams, and golds, while their inner regions held pressures unlike anything found on rocky planets. Gas giants became gentle giants of their systems, shaping the orbits of smaller worlds around them. And a bit farther out, another kind of planet formed beneath a veil of icy mist. Fact 53. Ice giants, wrapped in mist. Beyond the gas giants lay the ice giants, planets smaller than their gas-filled cousins, but still massive compared to Earth. These worlds were rich in water, methane, and ammonia ices, giving them their distinct, cool hues. Their atmospheres formed shimmering layers of haze, soft enough to blur their features into dreamy, pastel-colored spheres. Deep within, these planets held cold, dense mantles that blended seamlessly with thick atmospheres above. Their storms moved slowly, sculpting gentle bands of color instead of the wild tempests seen on larger giants. Though distant and dim, ice giants played a vital role in shaping the outskirts of their systems, influencing the paths of comets and distant debris. Encircling many of these giant worlds, moons began to form in quiet companionship. Fact 54. Moons rise beside their planets. Around growing planets, both gas giants and rocky worlds, smaller bodies form from leftover material. These moons began as drifting clumps within the young planet's gravitational reach, slowly gathering into spheres of rock or ice. Some were captured travelers, wandering objects drawn gently into orbit. Others formed in place, born from the same disk of swirling matter. Each moon carried its own personality. Some froze beneath thick crusts of ice. Some developed thin atmospheres. Others remained barren and cratered, untouched for billions of years. Yet all of them lived in the soft glow of their parent planet, rising and setting in long, slow arcs through alien skies. These moons became loyal companions in the quiet dance of planetary families. And beneath the surfaces of some, hidden oceans would soon begin to stir. Fact 55. Hidden oceans beneath shells of ice. Some icy moons hold extraordinary secrets beneath their frozen surfaces. While their outer shells appear rigid and still, deep below lies a world of warmth and motion. Tidal forces from their parent planets gently knead their interiors, creating heat that melts the ice into vast subsurface oceans. These oceans are completely dark, never touched by sunlight, yet they move in slow, steady currents. Minerals drift upward from rocky floors, mixing with cold water overhead, forming environments that may echo the early oceans of Earth. From the outside, these moons seem silent and unmoving, but within them, entire seas slosh softly in the dark. And above these hidden waters, thin atmospheres begin to whisper around forming worlds. Fact 56. Atmospheres. Learning to breathe. As planets and moons cooled, their surfaces released gases that rose to form the earliest atmospheres. These blankets of vapor began thin and delicate, shaped by volcanic breaths, icy sublimation, and the slow leak of chemicals from planetary crusts. Over time, these atmospheres thickened or thinned depending on gravity, sunlight, and chemical reactions unfolding quietly across eons. Some worlds developed dense, warm coverings that trapped heat. Others held only the faintest traces of gas, too light or too sparse to linger for long. But in each case, an atmosphere acted as a gentle mediator between surface and sky, softening temperature swings and creating space for new possibilities. These early breaths were the first steps toward climates and seasons. And amidst these shifting skies, some planets wore rings of quiet beauty. Fact 57. Rings made of dust and dreams. Rings formed around several young planets when leftover debris from collisions or moon-building events drifted into stable orbits. Instead of merging into larger moons, these tiny pieces of ice and rock remained suspended, circling their parent planets in shimmering bands. From afar, rings appear smooth and continuous, but up close they're made of countless individual particles, each reflecting light in its own subtle way. The rings are ever-changing, collisions reshaping them, sunlight sculpting their edges, and gravitational tugs from moons carving gaps and waves within them. Yet despite this quiet activity, they maintain a sense of serene elegance, like thin halos of pale light floating around distant worlds. Rings remind us that even broken pieces can create breathtaking beauty. And deeper within these systems, magnetic forces serenely guided planetary rhythms. Fact 58. Magnetic fields in gentle motion. Many planets develop magnetic fields, invisible shields that flow from their interiors into the surrounding space. These fields form when molten, electrically charged materials move within a planet's core, swirling slowly like warm currents beneath the crust. Though silent and unseen, magnetic fields act as protective blankets, guiding charged particles away and shaping elegant patterns known as magnetospheres. In some places, these fields funnel particles into a planet's atmosphere, creating soft auroras that shimmer near the poles. Even on distant worlds, these lights glow quietly, painting the sky with gentle waves of color. Magnetic fields help sustain atmospheres and soften the harshness of stellar winds. And within their shelter, storms can brew and swirl for centuries. Fact 59. Storms that last for centuries. On certain planets, especially the gas and ice giants, storms form with astonishing persistence. Unlike storms on Earth, which rise and fade over days, these immense tempests can endure for hundreds of years. They swirl in slow, deliberate spirals, driven by deep atmospheric currents and changes in temperature far below their cloud tops. From above, these storms appear as soft ovals, bands, or swirling patterns of color. Whites, blues, oranges, and reds blending like pigments in a softly stirred bowl. They move gracefully, shaped by winds that can circle the entire planet without interruption. Despite their size, these storms feel patient, almost meditative, spinning at the pace of planetary time. And far beyond them, in other star systems, stranger worlds wait quietly in the dark. Fact 60. Strange worlds. Beyond our sun. As telescopes grew more powerful, astronomers discovered that planets come in forms far beyond those in our own solar system. Some worlds orbit close to their stars, glowing red-hot with molten surfaces. Others drift in eternal twilight beneath thick atmospheres. A few wander alone between stars, bound to no sun at all, drifting like solitary travelers through the cosmic night. These exoplanets vary in size, color, temperature, and composition, forming a gallery of worlds more diverse than anyone once imagined. Some are covered in oceans deeper than Earth's, while others may have skies filled with shimmering crystals or clouds of glowing gas. Each world adds a new stroke to the universe's portrait of possibility. And among all these distant planets, one star was forming a very special home. Fact 61. The sun's birth among countless stars. Our sun began its life in a bustling stellar nursery, surrounded by hundreds, perhaps thousands, of sibling stars. Within a cool, drifting cloud of gas and dust, a dense pocket began to collapse under gravity's patient pull. As it drew in more material, its center grew warmer and brighter until, at last, fusion ignited. A soft golden glow spread outward, announcing the birth of a new star. The young sun shone gently at first, wrapped in the remnants of the cloud that formed it. Around it, other newborn stars flickered in shades of red and blue, forming a quiet family connected by their shared origins. In that radiant cradle, the sun found its place, and swirling around it, the beginnings of our solar system were stirring. Fact 62. A disk of gold and gray. After the sun's birth, the leftover gas and dust did not drift away. Instead, it settled into a wide, rotating disk around the young star. A soft, glowing ring that stretched for billions of kilometers. This protoplanetary disk shimmered in muted shades of gold, beige, and silver, warmed by the sun's early light. Within the disk, countless particles circled in patient orbits, brushing together, clustering, and pulling each other into new shapes. The inner regions glowed a little warmer, filled with rocky materials. The outer regions rested in cold shadow, where ice could thrive. This disk was the raw canvas from which planets, moons, comets, and asteroids would be drawn. And deep within it, one small world was beginning to take its earliest form. Fact 63. Earth's early, fiery face. Long before Earth became blue and calm, it was a molten sphere glowing like a soft ember. In its youth, countless impacts from drifting debris heated its surface, keeping it fluid and restless. Volcanoes erupted across its glowing crust, releasing gases that would someday form an atmosphere. Lava flowed freely, shaping mountains that rose and collapsed within the same span of cosmic moments. Yet even amid this fiery chaos, Earth was cooling bit by bit. Crust began to harden, forming the earliest foundations of continents. Minerals crystallized in shimmering layers, and vapor from the molten surface drifted upward to begin gathering as thick clouds. From this fiery beginning, the seeds of a habitable world slowly emerged. And soon, Earth would gain a companion that shaped its destiny. Fact 64. The Moon's silent arrival. In Earth's earliest days, a colossal collision reshaped its destiny. A wandering protoplanet, roughly the size of Mars, grazed Earth in a slow, glancing impact. Molten rock and vapor spiraled outward, forming a glowing ring of debris around our young world. Over time, that debris gathered into a single, luminous sphere, the Moon. When it first formed, the Moon glowed with molten light, slowly cooling into the quiet companion we know today. It drifted farther from Earth each year, settling into a gentle orbit that would stabilize our planet's tilt and shape the rhythms of tides. Though born from fire and impact, the Moon became a source of calm. And under its soft glow, Earth continued to cool and transform. Fact 65. The seas that gathered from vapor. As Earth's surface cooled, the thick steam in its atmosphere began to condense. For thousands of years, rain fell in steady, unbroken waves, warm at first, then cooler as the planet released its heat. These rains collected in vast basins, forming the first oceans, shimmering under a hazy sky. The early seas were mineral-rich and warm, their waters swirling with dissolved gases and elements from volcanic outgassing. Waves lapped against newborn shores, wearing grooves into stone and carrying nutrients across the globe. In these ancient waters, chemical reactions stirred softly, laying the foundations for life yet to emerge. The oceans became Earth's first cradle, vast and inviting. And above them, continents began drifting like slow-moving rafts. Fact 66. Continents drift like slow rafts. Beneath Earth's cooling crust, currents of molten rock continued to flow. These subtle motions caused large sections of the crust, tectonic plates, to drift slowly across the planet's surface. At first, the movements were small and scattered, but over millions of years, continents assembled, broke apart, and reformed in long, patient cycles. From above, the continents appeared to glide effortlessly, though their journeys took eons. Mountains rose where plates collided, while valleys formed where they drifted apart. The landscape was never fixed. It evolved at a pace too slow for any single moment to notice, yet powerful enough to shape entire eras. These drifting rafts helped sculpt oceans, climates, and habitats. And upon these changing lands, Earth was preparing for its next quiet transformation. Fact 67. Earth learns to calm. After its fiery beginnings, Earth gradually settled into a quieter rhythm. Volcanic eruptions became less constant, allowing the atmosphere to stabilize and cool. The crust thickened, forming stronger continents and calmer oceans. Winds softened, rainfall steadied, and sunlight filtered more gently through the thinning haze above. This newfound stability created a balanced environment where temperatures could hold steady for long stretches of time. The planet was no longer a molten battleground, but a world beginning to resemble the home we know. Quiet cycles emerged, day and night, tides and seasons, each one shaping the world with patience. In this calm, Earth became a nurturing place, and within its seas, something extraordinary was beginning to stir. Fact 68. The first sparks of life. Deep in the warm, mineral-rich oceans, simple molecules began to meet, merge, and assemble into complex structures. Over countless cycles, these structures learned to copy themselves, forming the earliest forms of life. These first organisms were tiny beyond imagining, fragile yet persistent, drifting through the water like soft murmurs of possibility. They fed on chemical energy from their surroundings, multiplying in slow, steady rhythms. Some clung to volcanic vents, warmed by heat rising from Earth's interior. Others floated freely in sunlit shallows. Though invisible to the naked eye, these simple cells began to change the chemistry of the planet, releasing oxygen and altering the atmosphere. From these humble beginnings, life took its first quiet breath, and with time, evolution would guide these cells into new shapes and forms. Fact 69. The long patience of evolution. Evolution unfolded gradually, shaped by countless small changes passed down through generations. Tiny variations helped some organisms survive more easily, allowing those traits to spread. Over millions of years, cells formed partnerships, combined into colonies, and eventually grew into the first multicellular life. The early oceans became a tapestry of simple creatures, soft-bodied forms drifting through currents, feeding on sunlight or chemical energy. Though their shapes were modest, their existence marked an astonishing transition. Life was becoming more complex, more diverse, more capable of shaping its environment. Evolution never rushed. It simply followed the quiet logic of time and survival, sculpting life with gentle persistence. And in these ancient waters, the spark of consciousness waited in distant possibility. Fact 70. The rise of consciousness. As life continued to change and diversify, some organisms developed nervous systems capable of sensing their surroundings. Simple awareness slowly blossomed into more complex forms. Creatures that could respond, adapt, and eventually learn. Over millions of years, eyes formed to gather light, limbs evolved to explore new spaces, and brains grew to interpret the world with increasing clarity. Consciousness wasn't a sudden leap, but a gentle ascent, a long unfolding of perception across time. Each evolutionary step built upon countless others, creating beings that could feel, remember, and eventually reflect. From these humble origins, sentient thought emerged. The quiet ability to wonder, to choose, and to understand. And with awareness came a deeper connection to the cosmos from which life arose. Fact 71. The gentle push of dark energy. While life evolved on Earth, the universe itself continued its expansive journey. Far beyond our world, something mysterious influenced the motion of galaxies. Dark energy, a subtle force that caused the expansion of the universe to accelerate. This push wasn't violent or sudden. It was gentle, steady, and nearly impossible to detect except through the drifting apart of galaxies. Dark energy filled all of space, woven into the very fabric of the cosmos. Its influence increased over time as galaxies grew farther apart, making the universe expand faster with each passing epoch. Though its nature remains unknown, its effect is unmistakable, a soft, persistent stretching of space. And under its guidance, galaxies drifted ever more quietly into the depths. Fact 72, a universe that quietly accelerates. As dark energy continued its subtle work, the large-scale structure of the universe began to spread more rapidly. Galaxies that once moved apart at a gentle pace gradually increased their separation. Over billions of years, this acceleration reshaped the cosmic landscape, thinning out the distances between clusters and leaving wide regions of emptiness in between. From the viewpoint of any single galaxy, this change was imperceptible from moment to moment. But across ages, the effect was profound. The sky grew a little lonelier, the connections between galaxies more tenuous and quiet. This accelerating expansion marked a new chapter in the universe's evolution, one defined by growing distance and softening interactions. And in this expanding canvas, deep mysteries still waited to be understood. Fact 73. The hidden majority of mass. Most of the matter in the universe doesn't shine, reflect, or interact with light at all. This unseen substance, dark matter, makes up far more mass than all the stars, planets, and galaxies combined. Though invisible, it reveals itself through gravity, gently pulling on what we can see and shaping the motion of galaxies with quiet strength. Dark matter forms vast halos around galaxies, cushioning them in invisible clouds that extend far beyond their visible starlight. Without this hidden mass, galaxies would fly apart. With it, they hold together in steady, graceful rotation. It is a silent presence, woven delicately through the fabric of space. And drifting alongside it are particles so elusive they pass through us by the trillions each second. Fact 74. Neutrinos passing like ghosts. Neutrinos are among the lightest and most elusive particles in existence. Created in stars, supernovae, and the earliest moments of the universe, they stream endlessly through space. Billions pass through your body every second without ever slowing down, slipping through matter as though it were empty air. Despite their ghost-like nature, neutrinos carry important information about the processes that create them. They whisper stories from the hearts of stars, from the cores of collapsing suns, and from the first seconds after the universe began. Most neutrinos never interact with anything at all, drifting through entire planets without leaving a trace. And beyond them, deeper still, lies a realm shaped by the subtlest of quantum murmurs. Fact 75. The subtle hints of symmetry. At the smallest scales of reality, nature follows patterns so delicate they resemble the symmetry of finely woven lace. Particles mirror one another in elegant arrangements, linked by mathematical relationships that guide how they interact. These symmetries help define the forces that hold atoms together, allow stars to shine, and shape the very structure of matter. Yet these patterns are not perfect. Tiny breaks in symmetry, small imperfections in the cosmic design, allow the universe to evolve and diversify. Without these gentle asymmetries, stars would not form, matter would not clump, and the cosmos would remain featureless. In every particle and every force, symmetry whispers its quiet influence. And within that whisper lies the foundation for even deeper mysteries. Fact 76. Quantum fluctuations. Soft murmur. Even in the calmest vacuum, space is never truly empty. Tiny quantum fluctuations ripple in and out of existence, appearing for the briefest moments before fading again. These fleeting events are subtle, quieter than the softest breath, yet they shape the earliest structure of the universe. During the first instance after the Big Bang, these fluctuations were stretched by rapid expansion, freezing their patterns into the fabric of space. Over billions of years, these minute variations guided matter into filaments, clusters, and galaxies. From near nothingness emerged the seeds of everything. And in the background of the cosmos, another form of quiet pressure continued to guide its evolution. Fact 77. Vacuum energies, quiet pressure. The vacuum of space possesses a faint, persistent energy, a soft hum that fills the universe even when all matter is stripped away. This vacuum energy contributes to the gentle push of dark energy, encouraging the expansion of space to continue and even accelerate over time. It is not a force in the dramatic sense, but a subtle, all-pervading influence. Across cosmic distances, vacuum energy creates a steady outward drift, stretching space in every direction. Galaxies feel this pull, not as a wind or a shove, but as an increase in the space between them, slowly widening the dark oceans in which they float. It is the universe's faint, constant exhale, and beneath that breath, four fundamental forces maintain the harmony of nature. Fact 78. Fundamental forces in harmony. All interactions in the universe, from the fall of an apple to the fusion within stars, are governed by four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. Each plays a different role, yet together they form a beautifully balanced system. Gravity shapes the grand structures of galaxies and planets. Electromagnetism guides light, chemistry, and electricity. The strong force binds the nuclei of atoms, while the weak force enables certain forms of decay that help create new elements. Though these forces differ in strength and reach, they work in seamless cooperation, supporting the complexity and stability of the universe. And within their harmony lies the delicate fine-tuning that makes existence possible. Fact 79. The delicate balance of constants. The universe is guided by a handful of physical constants, values so precise that even the slightest change would create a cosmos entirely unlike our own. These constants shape everything: the strength of gravity, the behavior of light, the charge of electrons, and the way atoms bind together. Each number sits within a narrow, delicate range, allowing stars to burn steadily and matter to assemble into stable forms. This balance is not rigid, but quietly harmonious, like notes in a cosmic chord tuned just right for structure and life to arise. The universe's beauty, from swirling galaxies to gentle breezes on Earth, depends on this fine-tuned arrangement. These constants form the quiet scaffolding of reality, and from within that delicate framework, the cosmos continues its slow journey into the future. Fact 80. The possibility of many universes. Some theories suggest that our universe may be just one of many, part of a vast multiverse where each universe has its own laws, constants, and conditions. If this is true, then countless other realities may drift beyond our reach, each with its own blend of light, matter, and time. Most of these hypothetical universes might be barren or silent, unable to host stars or life. but a few could resemble our own, with stable matter and gentle physics that allow complexity to bloom. Though we may never touch or observe these distant realms, the possibility expands our sense of wonder, reminding us that creation might be deeper and wider than we can imagine. And while these ideas linger at the edge of knowledge, our own universe continues to evolve toward distant chapters. Fact 81. Stars fading into crystal embers. Far in the future, long after familiar stars like our sun have lived out their days, the galaxy will settle into a quieter era. White dwarfs, the cooling remnants of countless stars, will slowly fade, their glow dimming over trillions of years. As they cool, their interiors may crystallize, turning into enormous spheres of cosmic diamond drifting through space. These crystal embers will shine faintly, their light soft and subtle, like distant lanterns in an ever-darkening night. Though they no longer burn with fusion, they remain as timeless reminders of the stars that once illuminated the cosmos. In this gentle fading, the universe enters a tranquil twilight, and beyond it, galaxies will begin to drift even farther apart. Fact 82. Galactic drift. Across ages. As the universe continues expanding, galaxies slowly drift apart, carried by the stretching fabric of space. Over billions upon billions of years, familiar neighbors slip beyond one another's reach, their light growing fainter as distances widen. This drift is not hurried or chaotic. It is calm, steady, and almost tender, like continents drifting across an unseen cosmic ocean. In this distant era, clusters remain bound together by gravity, but the spaces between them will swell until each cluster becomes an island of starlight in a deep, quiet sea. The night skies of far future worlds will hold fewer galaxies than ours, their presence fading softly into the background. This slow parting marks a new chapter in cosmic evolution, and in the dimming glow, stars will continue forming for a while longer. Fact 83. New stars in a slowing universe. Even as galaxies drift apart, within their own glowing spirals and clusters, pockets of gas will continue forming stars. The rate will slow. Fewer giant clouds, fewer bright births, but it won't stop immediately. Instead, new stars will arise gently, taking shape from the last reserves of interstellar gas. These future stars will be smaller and redder, glowing softly for trillions of years. Their light will be steady and patient, illuminating the darkness even as the cosmos grows cooler. Though the universe will no longer blaze with the brilliant fireworks of its youth, these quiet stars will bring a gentle warmth to the galactic night. Star formation will taper off, like embers settling in a long burning fire, and eventually, the smallest stars of all will dominate the scene. Fact 84. The last red dwarf's gentle glow. Red dwarfs are the smallest, coolest, and longest-lived stars in the universe. While massive stars burn quickly and end in dramatic bursts, red dwarfs sip their fuel slowly, glowing with soft, steady light. Some may live for trillions of years, far longer than the current age of the cosmos. In the universe's distant future, when brighter stars have faded, red dwarfs will still shine calmly, their dim, warm hues providing the last starlight the cosmos will know. Around them, planets may continue to orbit in quiet, steady rhythms, lit by a glow more like eternal dusk than day. These enduring stars are the universe's final candles, and when even they grow faint, only the quietest remnants will remain. Fact 85. Black dwarfs in endless night. After red dwarfs exhaust their gentle fuel, they will cool into dark, quiet remnants known as black dwarfs. These objects will no longer shine or warm their surroundings. Instead, they will drift silently through space, holding only the faint memory of the starlight they once released. Black dwarfs will be cold, dense, and nearly invisible, cosmic embers that have finally surrendered all their heat to the universe. Each one will carry within it the entire lifetime of a star, the calm glow, the long endurance, and the patient march toward stillness. These remnants mark the universe's slow transition toward darkness, and as stars fade, galaxies themselves will begin to fall quiet. Fact 86. Galaxies fall quiet. As trillions of years pass, the swirling activity within galaxies will gradually settle. Star formation will cease as gas supplies are exhausted, leaving galaxies filled mostly with aging stars, remnants, and cold dust. The luminous spirals and glowing clouds we know today will become rare memories, replaced by dimmer, sparser collections of long-lived stars. Galaxies will still rotate, but their vibrant structure will soften. No new clusters will form. No newborn stars will brighten the arms. Instead, galaxies will drift through space like faded lanterns, their once bright beauty dimmed by time. Even in this quieting, there is a gentle dignity, the calm rest after a long, radiant life. And within the darkening expanse, black holes will remain as the final architects of motion. Fact 87. Black holes reign in the dark. In the far future, when most starlight has diminished, black holes will become the dominant objects shaping the cosmos. They will continue to drift through space, merging occasionally in graceful spirals that release faint ripples through space-time. Their gravitational influence will guide the last remnants of matter, dead stars, lonely planets, and stray particles. Though often imagined as fierce, black holes in this era will be quiet rulers, presiding over a universe that has grown cool and still. Their presence will be subtle, their power immense, and their evolution slow. They are the final sculptors of cosmic structure in an age without light, and even they, in time, will begin to fade through the slow process of evaporation. Fact 88. The slow evaporation of giants. Even black holes, with their immense gravity and deep silence, are not eternal. Over unimaginable spans of time, they slowly lose mass through a process known as Hawking radiation. This evaporation is incredibly gentle, so slow that for most of cosmic history, it is imperceptible. Yet across trillions upon trillions of years, even the largest black holes will shrink, dim, and eventually vanish. In their final moments, they release the last whispers of energy back into the universe, completing a cycle that began with the birth of the first stars. Their quiet disappearance marks one of the final transformations of matter into light. After their passing, the cosmos will be left with very little structure at all. And in this widening quiet, the universe will continue to cool. Fact 89. A universe of cooling echoes. As black holes fade and starlight becomes a distant memory, the universe will drift into an age of deep, pervasive cold. Photons, the last traces of ancient light, will stretch into wavelengths so long they carry almost no energy. Matter will grow sparse, and interactions between particles will become rare and gentle, like whispers lost in a vast hall. Temperature will fall toward absolute zero, not with a sudden chill, but with an almost meditative stillness. Everything will slow: motion, collisions, and the faint tick of physical processes. The cosmos will become a place of echoing remnants, a quiet sea where time passes but little changes. This cooling marks the final approach to cosmic rest. and beyond it lies the soft continuation of endless expansion. Fact 90. A future of silent expansion. Even when stars have faded, galaxies drifted apart, and black holes vanished, the universe will continue to expand. Space itself will stretch into a boundless quiet, carrying the last particles to distances so vast they may never meet another companion again. Yet this expansion is not violent. It is serene, the gentle unfolding of a cosmos long past its days of light. In this era, the universe will be dark, still, and incredibly spacious, like a vast desert beneath an eternal night sky. Though almost all activity will have ceased, the expansion will continue indefinitely, spreading what little remains ever thinner. It is the quietest chapter of the cosmic story, a soft, unending drift into silence. And within that silence, meaning still waits to be found. Fact 91. From simplicity to stardust. The universe began with the simplest forms of matter: hydrogen, helium, and a quiet sea of particles drifting through expanding space. Yet from these modest beginnings, complexity slowly emerged. Gravity gathered clouds, stars forged heavier elements, and supernovae spread them like seeds across the galaxy. Over billions of years, these elements combined in countless ways, forming planets, oceans, minerals, and eventually living cells. The journey from simplicity to stardust-built worlds is one of gentle layering, each step adding new possibilities to the cosmic tapestry. Every tree, every stone, every heartbeat carries atoms shaped in ancient stars. And woven through all of this is a thread of quiet connection. Fact 92. The long thread of connection. Across all of time and space, everything is linked through shared origins. The atoms in distant galaxies mirror those on Earth. The starlight we see carries stories billions of years old. Even the elements within our bodies were forged by stars that lived and died long before the sun existed. This thread of connection is not dramatic. It is subtle and comforting. It reminds us that we are participants in a much larger story, woven from the same cosmic material as nebulae and oceans. When we look at the night sky, we are seeing distant echoes of our own beginnings. The universe holds us in a quiet embrace of shared heritage, and within that embrace, patterns whisper of the forces that shaped everything. Fact 93. Patterns that whisper of origins. Throughout the cosmos, patterns repeat in gentle, familiar ways. Spiral galaxies echo the swirls of hurricanes on Earth. Branching river deltas resemble the filaments of the cosmic web. Even the structure of trees and lightning reflects deeper principles shaped by physics and chance. These recurring forms are not coincidences. They arise naturally from the laws that guide motion, energy, and growth. By studying them, we can trace the story of how things form, settle, and evolve over time. Each pattern is a soft reminder that the universe is both creative and consistent. In every structure, large or small, the same quiet rules are at play. And from these rules emerges a cosmic poetry that invites contemplation. Fact 94. The poetry of physical law. The universe follows laws that are precise yet full of quiet elegance. From the way planets orbit their stars to the way light bends around massive objects, each interaction feels like a verse in an ancient cosmic poem. These laws don't shout or demand attention. They operate humbly in the background, guiding everything from tides to starlight. Even the smallest particles move in accordance with these principles, dancing through space in patterns both predictable and mysterious. The harmony of these laws allows galaxies to swirl, atoms to bond, and life to take root. Physics is not just a set of rules, It is the universe's soft, steady rhythm. And within that rhythm, time weaves its gentle influence. Fact 95. The tenderness of cosmic time. Time flows with remarkable patience across the cosmos. It allows stars to be born, live, and fade. It permits planets to cool, continents to drift, and life to evolve. There is no hurry in cosmic time. Its pace is soft and steady, unfolding each chapter with care. To us, a human lifetime feels brief, but to the universe, it is a delicate moment, a single note in a vast symphony. Yet within that moment, entire worlds of feeling, thought, and experience unfold. The cosmos holds space for all these scales of existence, from the blink of an atom to the lifespan of galaxies. Time is the quiet keeper of every cosmic story. And within those stories, awareness emerges in rare and precious forms. Fact 96. The rarity of awareness. Among all the transformations in the universe, awareness is one of the most extraordinary. It arises from matter arranged in subtle and complex patterns, allowing a being to sense, reflect, and understand. Conscious minds can look at the stars and wonder where they came from. A gentle curiosity that loops back to the very origins of everything. Awareness is rare, not because the universe resists it, but because it requires conditions so delicately aligned. Stable planets, liquid water, long stretches of calm, and billions of years of evolution. Yet where it appears, it brings a new layer of meaning to existence. We are the cosmos, learning to contemplate itself. And from that contemplation comes a deeper sense of connection to everything around us. Fact 97. The universe. Knowing itself. As awareness blossomed on at least one small world, the universe gained something entirely new: the ability to observe its own unfolding. Through curious minds and quiet questions, starlight was no longer just illumination. It became information, a message read by beings made of the very atoms forged in ancient suns. When we study galaxies, peer into nebulae, or ponder cosmic origins, the universe is, through us, reflecting upon its own history. We are stardust shaped into observers, carrying the memory of countless transformations within every cell. In our thoughts, the cosmos traces the arc of its own story, and through that story, we find our place among the stars. Fact 98. Our fleeting moment of light. Human existence spans only a whisper of cosmic time, yet within that whisper lies immense beauty. For a brief moment, we have the chance to see the universe in all its grandeur, to watch sunsets painted by atmospheric chemistry, to marvel at galaxies billions of years old, and to feel the warmth of a star we call the sun. Though our lives are short compared to the age of the cosmos, that brevity makes each experience more precious. Like sparks floating upward from a fire, we glow, not despite our transience, but because of it. Our moment of light is fleeting, but deeply meaningful. And through curiosity, we illuminate the darkness with understanding. Fact 99. The beauty of not knowing everything. For all we've learned, countless mysteries still drift quietly beyond our reach. What is dark matter? What lies beyond the edges of our observable universe? How did the first spark of existence truly begin? These unanswered questions aren't shortcomings. They are invitations. The beauty of the cosmos lies partly in what we understand, and partly in what remains just out of sight. Mystery keeps the universe vibrant, inspiring us to dream, explore, and imagine possibilities far beyond our current grasp. Not knowing everything makes the story feel alive, filled with pages still waiting to be turned. And as the last fact approaches, the tale circles back to where it began. An endless story, still unfolding. Fact 100. The story that never truly ends. Even in the quietest stretches of cosmic time, the universe continues its gentle unfolding. Though stars fade, galaxies drift apart, and matter grows sparse, the story itself remains open. A slow, endless motion woven into the fabric of space. In every particle, every shadow of light, and every whisper of energy, the memory of creation lingers. And here, in our brief moment, within this vast timeline, we add our own small chapter simply by wondering, listening, and dreaming. The cosmos moves forward, and we move with it. Tiny sparks carried along by currents older than time. The story does not end because the universe never stops becoming. It only invites us to rest and continue imagining what comes next. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. The universe is vast and full of wonder, yet in these quiet moments, it feels close, almost like a companion keeping you company as you drift toward sleep. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your suggestions help guide future voyages, and they help other sleepy travelers find their way here too. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.